Hello everyone, welcome to today's session. In the other session, we looked at the parts of a CRO, and today we'll be looking at some of the features of the CRO. We have the cathode ray oscilloscope with us here. We may not open it to see the inside of it, but we'll be looking at some of the things we talked about and that are controlled on the control panel of the CRO. This is the control panel, and we have the screen. If you can see, the screen has some graduations. It's a grid with squares of 1 centimeter. So one of the features we looked at in the CRO is the grid. And we said the grid helps in controlling the intensity of the spot, and the intensity is seen by the brightness. When the intensity is high, the spot is very bright. When the intensity is low, then the spot is dull. The grid do that by either having a high negativity, we can increase its negativity, or lower its negativity using the potential divider that divides the potential difference across it relative to the potential difference across the cathode. This potential divider here that controls the grid is connected to the intensity or the brightness knob on the control panel. This is the intensity knob. You can see the intensity knob here, or the brightness knob. After switching it off, you can see the spot on the screen, and by turning this knob, you can see the spot is becoming brighter, meaning we have a very high intensity, and that means that we have reduced the negativity of the grid. If we were to increase its negativity, you can see the brightness of the spot is reducing. The spot is now very dull, and we can turn it up to a point where we can no longer see the spot, meaning that the grid at this point is highly negative. It's allowing no cathode rays to pass through. So this is the intensity or the brightness knob that controls the potential divider that divides the potential difference which is across the grid. The other part that we looked at is the anode, and we found that the anode has two purposes. One is to accelerate the cathode rays towards the screen, and number two is to focus the cathode rays, that is to converge them. The anode as well is controlled by this potential divider here. The potential divider controls the voltage across, or divides the voltage across the two plates of the anode. When we make this one to have a very high voltage compared to the plate which is closer to the cathode, then the beam is highly focused due to the electric field that will be created between the two plates. This potential divider is controlled by the focusing knob on the control panel. This is the focusing knob, and you can see, even though this feature may not be very well captured by the camera, when I turn this, at that point I have a very sharp dot. That means that we have highly converged the cathode rays, and at the same time we can have this increased. The dot is now very big, meaning that it is not well converged. Therefore, the focusing knob controls the potential divider that divides the voltage across the anode. The other feature that we looked at is the deflecting the horizontal deflecting plates, that is the X plates, and we found that we have its input here, which is a special circuit we called the time base, and we can control the time base, we can control the way the dot is being deflected along the horizontal axis. This feature is controlled on the control panel with the time base control. It is set in time per division, and we call it time base because we set it regarding the time taken by the dot to cross over one dot, and this one dot is 1 centimeter by, that is 1 square is 1 centimeter by measurement. So we are looking at the time taken for the spot to cross 1 centimeter, 1 division. Then we have its settings. The highest setting of the time base here for the CRO is 0.2 seconds. This is 0.1 seconds. This time reduces now to milliseconds. You can see this is 50 milliseconds, 20, 10, and we reduce all the way from this point. Now we see this is in microseconds. So the lowest time base setting here, we can go all the way up to 0.1 microseconds. At this point, if we switch on the time base now, which is set at 0.2 seconds per division, when we look at the dot, we can see the dot moving across the screen. Remember, we said that this is a special circuit where we have cancelled out the current that would have made this dot to move back, and therefore the dot actually, after crossing over the screen, it flies back, moves, gets to the other point, flies back, moves. We can actually see the dot moving because the time base setting is at a very high time of 0.2 seconds. Therefore, this is a very low frequency. We can increase the frequency by reducing the time base setting. When we reduce the time base setting, I'm now setting it at 50 milliseconds per division. We can see the speed of the dot is increasing. And if we continue to reduce the time base setting, as we reduce the time, remember, the shorter the time taken to cross the dot, the higher the frequency. Now you can see the dot on the screen is seen to move very fast. We can still trace the dot moving, but the speed has increased. If I increase this time base, you can see now at that point we are almost forming or seeing a line. And if we reduce the time base now to a very low value, then on the screen what we see is a straight line. The dot is still moving across the screen, but at a very high frequency, too fast for our eyes to note. Remember also, this is assisted by the persistence of the vision of the eye and also the persistence of the glow of the screen or the fluorescent screen. The other thing we need to get very clearly is that when we talked of the tube being covered with graphite, that is, we have graphite on the tube, it's not the whole tube, but it is the tube that holds the screen. So this is the part that is covered with graphite. We looked at the importance of this graphite, including earthing the cathodes, that is the electrons, and also protecting the cathode from external electric field, as well as helping in accelerating the cathodes towards the screen. So at this point, we'll be looking at some of the uses of the CRO, and before we look at the uses, we'll just look at a demonstration of a use of the CRO. So one of the uses of the CRO that we'll be looking at is using the CRO. We use it to measure voltage. You know, the other device that we use to measure voltage is the voltmeter, and we'll be looking at the importance of this device in measuring the voltage compared to the voltmeter. For us to be in a position to measure the voltage, we connect the voltage to be measured across the Y plates, and then we switch off the time base. Then depending on the Y gain settings, this is the knob that we use to set the Y gain, and at this point you can see this is 5 volts. This is voltage. This is 5 volts. That means 5 volts per division. This is 2 volts per division, and we go all the way. We can go up to, we have on the other side, millivolts. So for example, I have some 2 cells here which are already used, therefore their voltage is not at maximum. And if you look at where the spot is, if I was to connect these at, or I set this voltage at 2 volts per division, when we connect, I would like you to look at the dot. You can see there is a slight displacement. So I can check to what extent or what is the magnitude at which the dot has been displaced vertically. And if we were to increase that Y gain voltage, you're using the same cells, but this time now we reduce. I'm turning it from 2 volts per division to 0.5 volts per division. And when we connect that again, we see now that the displacement is bigger than in the first case. Now we have moved about 0.8 of 1 centimeter, that is 0.8 centimeters. We can continue reducing this division, that is the Y gain setting, that is at 0.2 volts per division, and that will be marked by a bigger displacement along the vertical axis. You can see the dot has been displaced upwards, and if we are to interchange the terminals of the cells like we've done at this point, when we connect this way, the dot is moving upwards. If we interchange those terminals, you can see the dot will be displaced, but now downwards. The dot is being displaced downwards. We can continue reducing this Y gain setting. It's now at 0.1, and depending on the setting of the Y gain, then the displacement increases. The vertical displacement increases. So we'll be interested in how many divisions has the spot been displaced upwards. How many divisions has the spot been displaced upwards? So we'll be looking at this in our next session. Remember, we'll be able to interact with the CRO at close range when we come back. At this time, through the video, we can't do much, as we hope that the little that we have seen on the CRO will enhance our understanding of the cathode ray oscilloscope. Thank you very much. Let's meet in our next session. Thank you.